Hi, I'm Alex. We spend our entire lives believing Earth is large, solid, permanent. But today, we're going to strip away that illusion layer by layer, scale by scale. Because when you measure Earth against the full size of the universe, something unsettling happens. Our planet doesn't shrink, it loses all meaningful size altogether. The Earth effectively vanishes. Stay with this journey, and you'll never look at the ground beneath your feet the same way again. If journeys like this spark your curiosity, a gentle subscribe helps this channel keep growing. Now let's begin. In 1990, the Voyager spacecraft turned its camera back toward Earth from 3.7 billion miles away. What it captured was shocking. Earth appeared as a pale blue dot, barely visible, less than a single pixel in size. That tiny speck suspended in a sunbeam is home. That's us. Every human who ever lived there. Here's something that will stop you in your tracks. If the universe were the size of a football field, Earth would be smaller than a bacterium. Actually, it would be far smaller than that. From the nearest star, just our closest neighbor, in space we are completely invisible. Not small, not tiny, completely and utterly invisible. What you're about to discover will change everything. The things you worry about, the arguments you have, the stress you carry, all of it is happening on something so unimaginably small that the word small doesn't even begin to describe it. Arguing over a parking spot, hold that thought. Let's see what you're actually fighting over. From where we stand, Earth seems enormous. It feels infinite. The surface area is about 197 million square miles. That's genuinely vast from a human perspective. If you wanted to visit every single square mile and spent just 1 second at each location, it would take you over 6 years of continuous travel, without sleeping, without stopping, without rest. Walk around the equator at a steady pace of 3 miles per hour, 8 hours a day, and it would take you about 3 years and a month. The United States, one of the largest countries, covers only about 3.8 million square miles. That's less than 2% of Earth's total surface. From a human perspective, Earth is genuinely large. It's vast. It's almost incomprehensible in scale. To early humans, Earth was everything. It was the entire universe. The sky was just a dome with lights fixed to it. The ground beneath went on forever in all directions. This made complete sense based on what they could see. When you look at the horizon, Earth does appear flat. The curve is too subtle to notice from the surface. But here's where things begin to shift. Let's talk about the Moon, our nearest neighbor. The Moon orbits Earth at an average distance of about 238,855 miles. That seems far, and it is far by human standards. But here's what most people don't realize. The distance between Earth and the Moon is about 30 times Earth's diameter. Imagine placing 30 Earths in a line between us and the Moon. That's how much empty space exists in that gap. When you see pictures of Earth and the Moon together, they're usually shown much closer than they actually are. The reality is that there's a vast amount of nothing between us and our closest companion. This is your first hint that space is mostly empty. Even in our immediate cosmic neighborhood, the distances are enormous compared to the sizes of the objects themselves. Most of what's out there isn't stuff. It's emptiness. It's void. It's nothing. Space isn't filled with objects. It's filled with nothing, with occasional objects scattered impossibly far apart. This story is going to change everything you think about big and small. Because what seems big to us, what seems vast and infinite, is actually incomprehensibly tiny when you zoom out just a little bit. And as we keep zooming out, Earth doesn't just get smaller. It doesn't just shrink. It vanishes completely. The illusion we live under is profound. We think we're on something large, something significant. We're not. We're on a speck so small that from even modest cosmic distances, it becomes invisible. But wait, you think the moon is far away? You think 238.855 miles is a lot. You haven't seen anything yet. Let's talk about the sun. This is where Earth's size truly begins to collapse into insignificance. The sun has a diameter of about 864,000 miles. That's 109 times larger than Earth's diameter. But diameter doesn't tell the full story. Volume does. The sun's volume is so immense that approximately 1.3 million Earth-sized worlds could fit inside it. Read that again. 1.3 million Earths could be packed into the sun. Every mountain range on Earth, every ocean, every city, every forest, every person who has ever lived all of human history, everything that has ever mattered to us, happened on a planet whose volume represents less than 1/1,000,000th of the sun's interior. Here's something even more staggering. Every single second, the sun produces more energy than all of human civilization has produced in its entire history. Every second. Not every day, not every year, every single second. The power output is beyond comprehension. The sun converts about 600 million tons of hydrogen into helium through nuclear fusion every second, releasing energy that dwarfs anything we've ever created. The core of the sun reaches about 27 million degrees Fahrenheit. Nothing we know could survive there. The atoms themselves are torn apart. The pressure at the core is about 260 billion times Earth's atmospheric pressure. These aren't just big numbers. These are conditions so extreme that they're almost impossible to conceptualize. The sun sits about 93 million miles away from Earth. Light from the sun takes about 8 minutes and 20 seconds to reach us. Here's a terrifying thought. If the sun suddenly disappeared right now, we wouldn't know for over 8 minutes, because the light telling us it's gone would still be traveling toward us. We'd continue living normally, completely unaware that our star had vanished until that final wave of light arrived. Then darkness, then cold, then death. And here's the truly frightening reality. The sun contains 99.86% of all the mass in our solar system. Everything else, all the planets, all the moons, all the asteroids, all the comets, all the dust, everything combined makes up only 0.14%. The sun isn't just the largest object in our solar system. It is the solar system with a few scraps left over. Earth compared to the sun, imagine a peppercorn next to a basketball. Actually, no, that's far too generous. It's worse than that. Much, much worse. The comparison is almost meaningless because the scale is so extreme. But here's what's truly humbling. The sun, this massive object that dominates our entire solar system, that contains over 1,000,000 Earths, that produces incomprehensible amounts of energy every second, is actually just an ordinary star. Astronomers call it a yellow dwarf. It's average, common, unremarkable. There are billions just like it in our galaxy alone. And this is just the beginning. The sun just a normal, middle-sized star. Now let's zoom out further and look at the other planets in our solar system. Because if the sun made Earth seem small, the giant planets are about to make things even more absurd. Jupiter is a monster. It's a gas giant so massive that 321 Earths could fit inside it. Read that again. 1,321 Earths. Jupiter contains more mass than all the other planets in the solar system combined. It's not just big, it's stupidly, incomprehensibly big. Jupiter has a feature called the Great Red Spot. It's a storm, and this storm is larger than Earth. The entire planet we live on could fit inside a single storm on Jupiter. And here's what's truly insane about it. This storm has been raging for over 400 years, longer than the United States has existed, longer than most nations have existed. A single storm bigger than our entire world, spinning continuously for centuries. Then there's Saturn. Saturn is nearly as large as Jupiter. About 764 Earths could fit inside Saturn's volume. But Saturn's most distinctive feature is its ring system. Those magnificent rings extending tens of thousands of miles from the planet's surface. And here's something remarkable. If you scaled Saturn down to the size of a basketball, those rings would be thinner than a piece of paper. They're incredibly thin relative to their width. Moving outward, we encounter the ice giants. Uranus is tilted on its side at about 98 degrees. Something massive must have hit it billions of years ago and knocked it over. Its axis of rotation is nearly parallel to its orbital plane. This means one pole points almost directly at the sun during Uranus's summer, while the other is in complete darkness. Each season lasts about 21 Earth years. Imagine a summer that lasts 21 years, followed by a winter that lasts 21 years. That's Uranus. Neptune, the farthest planet from the sun, is a violent world. Wind speeds on Neptune reach up to 1,200 miles per hour. That's the fastest wind in the entire solar system. These are winds so powerful, they would instantly tear apart anything we could build. The planet is so far from the sun that it takes about 165 Earth years to complete one orbit. Since Neptune was discovered in 1846, it has barely completed 2 full trips around the sun. Let's talk about Mars for a moment, because Mars tells a sad story. Mars once had liquid water on its surface. Ancient riverbeds and lake beds are clearly visible in images from Mars orbiters. It had an atmosphere. It might have had life, but Mars is smaller than Earth, and its core cooled and solidified. When that happened, Mars lost its magnetic field. Without a magnetic field to protect it, the solar wind slowly stripped away Mars's atmosphere over hundreds of millions of years. The planet died. It's still there, but it's a dead world. Cold, dry, lifeless. Here's a scale comparison that puts everything in perspective. If the sun were the size of a basketball, Earth would be a peppercorn positioned about 26 feet away. Jupiter would be about the size of a golf ball. Saturn would be slightly smaller. And Neptune would be over 800 feet away in this model. The solar system is vast beyond normal comprehension. But here's what you need to understand. The entire solar system, with all these planets, all these moons, all these distances, all of it is just a point in the emptiness of space, a tiny dot. When you zoom out just a little bit more, when you look at our solar system from outside, it all collapses into a single point of light, and Earth disappears completely. Beyond Neptune lies a region most people have never heard of, the Kuiper Belt. This is a vast disk of icy objects stretching billions of miles beyond the orbit of Neptune. Thousands upon thousands of frozen worlds drift in the outer darkness. Pluto, once considered our 9th planet, is just one object among thousands in this belt. It's not special. It's not even particularly large by Kuiper Belt standards. But the Kuiper Belt isn't the edge of the solar system, not even close. Far beyond almost incomprehensibly distant lies the Oort cloud. This is a vast spherical shell of icy objects surrounding our solar system like a cosmic bubble. It begins at about 2,000 times the Earth-Sun distance. We call that distance an astronomical unit, or AU. So the Oort cloud starts at about 2,000 AU and extends outward to nearly 100,000 AU. That's almost 2 light years from the Sun. Here's something that should terrify you. No human has ever seen an Oort cloud object directly. We can't. They're too far away and too faint for our telescopes to detect. We only know the Oort cloud exists because occasionally a gravitational disturbance will send one of these objects falling toward the inner solar system. It becomes a comet. The comet's icy surface vaporizes as it approaches the sun's warmth, creating the tail we see in the night sky. Let's talk about Voyager 1. It launched in 1977. It's been flying through space for 47 years now, traveling at about 38,000 miles per hour. That's incredibly fast by human standards. After 47 years of continuous travel, Voyager 1 has covered about 15 billion miles. That seems like an enormous distance, and it is by human standards. But here's the reality. To reach the nearest star, Proxima Centauri Voyager 1 would need to travel for 73,000 years. 73,000 years. The entire span of recorded human history is only about 5,000 years. Voyager would need to travel for more than 14 times the entire length of human civilization just to reach our nearest neighbor. The solar system extends for trillions of miles. Not billions, trillions. The Oort cloud alone stretches for nearly 2 light years. That's the distance light traveling at 186,000 miles per second covers in 2 years. It's a distance so vast that normal units of measurement become meaningless. Here's a comparison that might help, though honestly, nothing really helps at this scale. Remember our earlier comparison where the distance from Earth to the Sun was 1 inch. At that scale, the nearest star would be about 4 miles away. 4 miles, and the solar system itself would extend for about half a mile in all directions. Voyager has been running away from home for 47 years. It's still in the yard. It hasn't even reached the sidewalk yet. If you think this part is mind-boggling, I need to warn you. This is just the beginning. What we've covered so far, the entire solar system, with all its planets and its vast distances, is nothing. It's a speck. It's a dot. It's less than insignificant when you zoom out to the next level, because the distance to the next star will make you stop breathing. Let's talk about our nearest stellar neighbor, Proxima Centauri. It's the closest star to our Sun, and when I tell you how far away it is, you're going to understand why space travel is so incredibly difficult. Proxima Centauri sits 4.24 light years away from us. That's about 25 trillion miles. Let me say that again. 25 trillion miles. That's not a million, not billion, trillion. Here's another way to think about it. Remember that distance from Earth to the Sun, that 93 million miles. We talked about Proxima Centauri is 268,000 times farther away than that. If you could somehow drive to the Sun at highway speeds, it would take you about 176 years. To reach Proxima Centauri at those same speeds, about 47 million years. Even with our fastest spacecraft, the journey seems impossible. The Parker Solar Probe, which travels at speeds exceeding 400,000 miles per hour, would still need about 600 years to reach Proxima Centauri. And that's not even aimed in that direction. Let's imagine we could build something far beyond our current technology. A spacecraft that could travel at 10% the speed of light. That's incredibly fast, far beyond anything we can currently achieve. Even at that extraordinary speed, the journey would still take 42 years. 42 years traveling at 67 million miles per hour. Think about what that means. You'd launch as a young astronaut and arrive as an elderly person, assuming you survived the journey at all. Now, what exactly is Proxima Centauri? It's what astronomers call a red dwarf star. These are the smallest, coolest types of stars that exist. Proxima Centauri has a diameter of only about 129,000 miles. That's roughly 14% of the Sun's diameter. Its mass is only about 12% of the Sun's mass. Because Proxima Centauri is so small and cool, it burns its fuel incredibly slowly. This little star will keep shining for trillions of years long, after our sun has died and gone cold. In fact, here's something remarkable. No red dwarf star anywhere in the universe has ever died of old age. The universe simply isn't old enough yet. Every red dwarf that has ever formed is still burning today. But don't let its small size fool you. Proxima Centauri is violent. It's what's called a flare star. It regularly produces powerful flares, sudden explosive releases of energy that can temporarily increase its brightness dramatically. These flares unleash torrents of radiation that would be devastating to any nearby planets. And here's the fascinating part. Proxima Centauri does have planets, at least 2 that we know of. One of them, called Proxima Centauri B, orbits in the star's habitable zone. That's the region where temperatures could allow liquid water to exist on a planet's surface. But here's the problem. Those flares we mentioned, they would bombard Proxima B with intense radiation. Any atmosphere the planet might have could be stripped away. Any life trying to exist there would be sterilized by the radiation bursts. So, while Proxima B sits in the right place for life, the violent nature of its star makes life there seem unlikely. Now here's something that really puts our cosmic insignificance into perspective. If you were somehow standing on a planet orbiting Proxima Centauri, and you looked back toward our solar system, what would you see? You wouldn't see Earth. You wouldn't see any of the planets. You'd see the sun as a bright star in the sky, similar to how we see Sirius or other bright stars. But Earth would be completely invisible, lost in the sun's glare, too small, too faint, too close to its star to be detected even with powerful telescopes. From our nearest stellar neighbor, a mere 4.24 light years away, Earth doesn't just become tiny, it becomes invisible. It ceases to exist as far as observation is concerned. Your nearest neighbor, 25 trillion miles away. Don't expect to borrow a cup of sugar anytime soon. And here's what should really make your head spin. This is the closest star to us. There are billions more stars in our galaxy alone, and most of them are much, much farther away. Let's explore the incredible variety of stars that populate our galaxy, because stars come in an astonishing range of sizes, temperatures, and lifespans. Red dwarfs, like Proxima Centauri, are by far the most common type of star in the Milky Way. They make up about 70% of all stars. These small, cool stars are the marathon runners of the cosmos. They burn their fuel so slowly that they can shine for trillions of years. And here's something mind-blowing. Not a single red dwarf star has ever died of old age. Not one. The universe is only 13.8 billion years old. And even the oldest red dwarfs will keep burning for the trillions of years more. The universe simply hasn't existed long enough for any of these stars to run out of fuel. Every red dwarf that has ever formed is still shining somewhere out there right now. Now let's look at the brightest star in Earth's night sky, Sirius. It's about 8.6 light years away, roughly twice the distance to Proxima Centauri. Sirius is a much larger and hotter star than our Sun. It's about 7 times the Sun's diameter and about twice as massive. Because it's so much hotter and more massive, it burns through its fuel much faster. Sirius will only live for about 1 billion years total compared to the Sun's 10 billion year lifespan. But Sirius is still relatively modest compared to the true giants of our galaxy. Consider Betelgeuse. This is a red supergiant star in the constellation Orion, and it's one of the most famous stars in the night sky. Betelgeuse sits about 700 light years away from us. The light you see when you look at Betelgeuse left that star around the time of the Crusades, around the year 1300. Betelgeuse is enormous. Its diameter is roughly 617 million miles. That's about 700 times larger than the Sun. If you placed Betelgeuse where the Sun is, it would extend past the orbit of Mars. Earth, Venus, Mercury, and Mars would all be inside the star, vaporized instantly. Think about that for a moment. Our entire inner solar system, everything from the Sun out to Mars, would fit inside Betelgeuse with room to spare. The star is so large that if you were traveling at the speed of light, it would take you more than 45 minutes just to cross from one side to the other. But Betelgeuse isn't even close to the largest star we know. Scuti, located about 9,500 light years away, is one of the largest known stars in the universe. Its diameter is approximately 1.7 billion miles. That's about 1/900 times larger than the Sun. If you replace the Sun with Scuti, this stellar giant would extend past the orbit of Saturn. The volume of Scuti is so staggering that approximately 6.5 trillion Earth-sized spheres could fit inside it. 6.5 trillion. That number is so large, it becomes almost meaningless to the human mind. These hypergiant stars are incredibly rare and incredibly short-lived. Because they're so massive, they burn through their fuel at an enormous rate. Scuti will only live for a few million years total before it explodes in a supernova. It's already near the end of its life. The diversity of stars is stunning. From red dwarfs smaller than Jupiter to hypergiants that could swallow our entire inner solar system, from stars that will burn for trillions of years to stars that live only a few million years before exploding. And here's what's remarkable. Every single star you can see with your naked eye on a clear night, every single point of light in the sky belongs to our galaxy, the Milky Way, all of them. But all those stars, all those thousands of points of light you can see, represent only a tiny fraction of the stars in our galaxy. Most stars are too distant or too faint for us to see without telescopes. But all the stars we've talked about, they're just a tiny corner of something much larger. Now we're going to zoom out to see the full structure of our home galaxy, the Milky Way, and the scale is about to become truly incomprehensible. The Milky Way is a spiral galaxy roughly 100,000 light years across. Remember, Proxima Centauri is 4.24 light years away. The width of our entire galaxy is about 24,000 times that distance. If the distance to Proxima Centauri was 1 inch, the Milky Way would stretch about 2,000 feet across, taller than most skyscrapers. How many stars does the Milky Way contain? We don't know exactly. Astronomers estimate somewhere between 200 billion and 400 billion stars. Let's use a middle estimate of 300 billion stars. That's 300,000 stars. Most of them are red dwarfs, small and faint. But there are also billions of stars, like our Sun, and millions of giants and supergiants. Our Sun sits about 26,000 light years from the galactic center. We're not in the middle of anything special. We're out in what you might call the suburbs of the galaxy. in a minor spiral arm called the Orion Spur. We're about halfway out from the center to the edge. The galaxy rotates, but not like a solid disk. Different parts orbit at different speeds. Our sun takes about 225 million years to complete one full orbit around the galactic center. Astronomers call this period a galactic year or cosmic year. Think about that time scale. The last time the sun was at this exact position in its orbit, dinosaurs were just beginning to emerge on Earth. The time before that, all the continents were joined together in the supercontinent Pangaea. Earth has existed for only about 20 galactic years. The entire universe has only been around for about 60 galactic years. At the center of the Milky Way sits something extraordinary, a supermassive black hole called Sagittarius A star. This black hole has a mass about 4 million times the mass of our sun. It's roughly 17 times the size of the sun in diameter, which might not sound that impressive. But remember, this is a black hole. All that mass is compressed into a relatively tiny space. Stars orbit this black hole at incredible speeds. One star called S2 completes an orbit every 16 years. At its closest approach, S2 travels at about 5% the speed of light. That's roughly 33 million miles per hour. The gravity near the black hole is so intense that space and time are significantly warped. Now let's talk about scale. If you somehow compressed the Milky Way down to 100 feet across our entire solar system, from the sun out to the Oort cloud would be thinner than a human hair, and Earth would be far smaller than an atom in that model. You couldn't see it with any microscope. It would be utterly, completely invisible. Finding Earth in the Milky Way, it's like trying to find a single atom in the entire city of New York. At this scale, Earth doesn't just become small, it transcends smallness and approaches something like non-existence. The difference in scale is so vast that comparison becomes impossible. And here's where the story becomes truly insane. Because the Milky Way, this enormous structure, containing hundreds of billions of stars spanning 100,000 light years across, it's just one galaxy among thousands of billions of others. The Milky Way isn't alone in space. It has neighbors. About 50 galaxies, including ours, form what astronomers call the local group. This is our immediate cosmic neighborhood, spanning roughly 10 million light years across. The largest member of the local group is the Andromeda Galaxy, also called M31. Andromeda is spectacular. It contains about 1 trillion stars, more than twice what the Milky Way has. Its diameter is roughly 220,000 light years across, making it more than twice the width of our galaxy. And here's something both fascinating and slightly terrifying. Andromeda is heading straight toward us. The Andromeda Galaxy is rushing toward the Milky Way at about 250,000 miles per hour. In approximately 4.5 billion years, the two galaxies will collide. Now, before you panic, understand that when galaxies merge, the stars are so incredibly far apart that actual collisions between individual stars are extraordinarily rare. What will happen is this: the two galaxies will pass through each other like two clouds of smoke interpenetrating. Their gravity will pull them back together. They'll pass through each other again. Eventually, after several passes, over hundreds of millions of years, they'll settle into a single large elliptical galaxy. Astronomers have already given this future merged galaxy a name. Some call it Milkomeda. Others prefer Andromilky. Either way, it will be a massive elliptical galaxy containing roughly 1.3 trillion stars. By the time this merger happens, the sun will likely be dead or dying anyway. So humans, if we still exist and haven't left Earth, will have much bigger problems than the galactic merger. But it's a reminder that even on cosmic scales, things are constantly changing and moving. The local group also contains the Triangulum galaxy, which has about 40 billion stars, and dozens of smaller dwarf galaxies. The large and small Magellanic Clouds, visible from the southern hemisphere, are dwarf galaxies orbiting the Milky Way. Both are being slowly torn apart by our galaxy's gravity and will eventually be completely absorbed. But the local group is just one small collection of galaxies in a much larger structure. About 54 million light-years from us sits the Virgo cluster. This is an enormous collection of galaxies containing somewhere between 200 and 2,000 individual galaxies. The Virgo cluster is the gravitational center of our larger neighborhood. In fact, the local group is slowly falling toward the Virgo cluster, pulled by its immense combined gravity. At the heart of the Virgo cluster sits M87, a giant elliptical galaxy. M87 contains roughly 1 trillion stars and is far more massive than the Milky Way. At its center lurks a supermassive black hole with a mass about 6.5 billion times the mass of our Sun. This is the black hole that made headlines in 2019. The Event Horizon Telescope collaboration released the first ever direct image of a black hole's shadow, and it was M87's black hole. That image showed a glowing ring of superheated matter swirling around the black hole's event horizon, with the dark shadow of the black hole itself at the center. Think about what that means. We managed to photograph the shadow of a black hole 54 million light-years away. A black hole 6.5 billion times more massive than our Sun. The Virgo cluster is impressive, but it's just one cluster among many. The local group and the Virgo cluster, along with dozens of other galaxy groups and clusters, form an even larger structure called the Virgo supercluster. The Virgo supercluster spans approximately 110 million light-years across. It contains at least 100 galaxy groups and clusters with a total of somewhere around 100 trillion stars. That's 100,000 stars, all bound together by gravity into one massive structure. If we made a scale model where the Milky Way was the size of a coin, the Virgo supercluster would be about the size of a large city. Everything we've talked about up to this point, the Sun, the solar system, the distances between stars, the entire Milky Way with its hundreds of billions of stars, all of that would fit on a single coin in this model. And Earth would be far smaller than any particle you could detect with any instrument. It would be smaller than a quark, smaller than anything that has a size in physics. Earth would effectively not exist at this scale. The Virgo supercluster seemed like it might be the largest structure in the universe. For a long time, astronomers thought superclusters were as big as structures got. But in 2014, they discovered something even larger. Even the Virgo supercluster is just a small piece of something much bigger. In 2014, astronomers made a stunning discovery. The Virgo supercluster isn't a distinct structure at all. It's just one small part of an even more massive structure called Laniakea. The name comes from Hawaiian and means immeasurable heaven. It's a fitting name. Laniakea is a supercluster of superclusters. It contains approximately 100,000 galaxies spread across 520 million light-years. All these galaxies, including our Milky Way, are slowly moving toward a common center, pulled by the combined gravity of all that mass. The center of Laniakea The point toward which everything is flowing is called the Great Attractor. This is a region of space with such enormous gravitational pull that it's drawing in thousands of galaxies from hundreds of millions of light years away. Here's what makes the Great Attractor particularly mysterious. It sits behind the plane of the Milky Way from our perspective. Dust and gas in our own galaxy block our view of it in visible light. For decades, astronomers knew something massive was there because they could measure its gravitational effects, but they couldn't see it directly. Using different types of light radio waves, infrared and X-rays, astronomers have pieced together what the Great Attractor is. It's not a single object, but a region containing several massive galaxy clusters. The Norma cluster is one of the largest structures in that region, containing thousands of galaxies. But even the Great Attractor isn't the whole story. Recent observations suggest there's something even more massive beyond Laniakea pulling it. The Shapley supercluster, located about 650 million light years away, contains thousands of galaxies and has a total mass of about 10,000 trillion times the mass of the Sun. The combined gravity of the Shapley supercluster appears to be pulling Laniakea and everything in it. At this scale, we need to talk about the cosmic web. When astronomers map out the distribution of galaxies across the universe, a remarkable pattern emerges. Galaxies aren't randomly scattered through space. Instead, they cluster along massive filaments and walls, forming a structure that looks like a gigantic cosmic web. Between these filaments are vast empty regions called voids. One of the largest known structures is the Sloan Great Wall, discovered in 2003. This is a wall of galaxies stretching about 1.37 billion light years across. It contains tens of thousands of galaxies arranged in a relatively thin sheet, but even that pales in comparison to the Hercules Corona Borealis Great Wall, which might be the largest structure ever discovered. It stretches approximately 10 billion light years across. That's about 73% of the radius of the observable universe. Structures this large actually created problems for cosmologists, because according to our models of how the universe evolved, there shouldn't have been enough time for something this enormous to form. Between these massive walls and filaments are the voids. These are regions where very few galaxies exist. The largest known void is the KBC void, about 2 billion light years across. It's not completely empty, but the density of galaxies is much lower than in surrounding regions. Here's what's truly staggering. These voids make up about 80% of the universe's volume. Most of the universe is empty. The galaxy's superclusters and filaments occupy only about 20% of the total volume. The universe is like a vast cosmic sponge, with matter concentrated along the walls and filaments and enormous empty bubbles in between. The universe is like a gigantic piece of foam, and we're living on one bubble in that foam. This is the point where the story exceeds human imagination. Our minds simply weren't built to comprehend structures measured in billions of light years. We can write down the numbers, we can do the math, but truly grasping what these scales mean becomes impossible. And here's the truly mind-breaking part. Everything we've just talked about, all those galaxy groups, clusters, superclusters, the cosmic web stretching billions of light years across, that's only the part of the universe we can see. The observable universe is the part of the universe we can theoretically see. It's limited by the speed of light and the age of the universe. Light from anything farther away then a certain distance hasn't had time to reach us yet. The universe is about 13.8 billion years old. You might think this means we can see 13.8 billion light years in every direction, but the universe has been expanding the whole time. Space itself has been stretching. So, a galaxy that emitted light 13 billion years ago has moved much farther away during the time its light traveled toward us. The result is that the observable universe is about 93 billion light years in diameter. That's the maximum distance from which light has had time to reach us, accounting for the expansion of space. Within this observable universe, astronomers estimate there are about 2 trillion galaxies. 2 trillion, each containing anywhere from millions to trillions of stars. The total number of stars in the observable universe is estimated at around 200 billion trillion. That's 200,000, thousand, 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 thousand stars. For comparison, if every star was represented by a grain of sand, you would need several Olympic-sized swimming pools to hold them all. And Earth. If you randomly selected one star from all the stars in the observable universe, the chances of picking our sun are 1 in 200 billion trillion. That's 1 in 200,000, thousand, 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 thousand. And even if you somehow picked the sun, you'd then have to select Earth out of 8 planets, dozens of moons, and countless asteroids and comets. The chances of randomly selecting Earth out of all the objects in the observable universe are so small that the number is effectively 0. Earth is not just rare, it's vanishingly rare. But here's something that should truly break your brain. The observable universe is just what we can see. The actual universe is almost certainly much larger. How much larger, we don't know. It might be a few times larger than what we can see. It might be thousands of times larger. It might be infinite. If the universe is infinite, then the observable universe is basically nothing. No matter how large 93 billion light years seems, it's still exactly 0% of infinity. And Earth would be even less significant in an infinite universe than it already is in the observable universe. Some theories in physics suggest the universe might be part of a multiverse, an infinite collection of universes. According to eternal inflation theory, the Big Bang wasn't a single event, but something that happens constantly, creating bubble universes that spawn more bubble universes. Our universe would be just one bubble in an infinite foam. Other interpretations of quantum mechanics suggest that every time a quantum event has multiple possible outcomes, the universe splits into multiple branches, with each outcome occurring in a different branch. This would create an infinite number of parallel universes. These ideas are speculative. We have no way to observe other universes, so testing these theories is extremely difficult. But they arise naturally from well-established physics, which is why many physicists take them seriously. If the multiverse exists, then our entire universe, with its 93 billion light-year diameter and 2 trillion galaxies, is just one universe among infinitely many, and Earth becomes even more vanishingly insignificant. This raises a profound question. If the universe is this vast, if there are this many stars and planets, shouldn't life be common? And if life is common, where is everybody? This question is known as the Fermi paradox. If intelligent civilizations exist, why haven't we detected any sign of them? Why is the universe so silent? So, why do we matter in all this vastness? In 1990, the Voyager 1 spacecraft, which had completed its primary mission and was heading out of the solar system, turned its camera back toward Earth and took a photograph from about 3.7 billion miles away. Earth appeared as a tiny pale blue dot, less than a single pixel in size, suspended in a beam of sunlight. This photo is one of the most profound images ever captured. It shows Earth as it really is in the context of space, a tiny speck floating in an enormous void. The astronomer Carl Sagan reflected on this image in his book Pale Blue Dot. He wrote about how every human who ever lived out their entire life on that tiny speck. Every king and peasant, every hero and villain, every creator and destroyer of civilization, all of them lived on that dot. All our triumphs and tragedies, all our wars and peace, everything that has ever mattered to humanity happened on that barely visible speck. Every border we've fought over, every resource we've competed for, every conflict between nations, every argument, every moment of anger and hatred, all of it took place on a stage so small that from a modest distance, it disappears entirely. Think about that the next time you're stuck in traffic, angry about politics, or arguing on social media. You're doing all of that on a speck of dust floating through infinite space. This perspective should change how we see ourselves and our world. But here's what makes it even more profound. As far as we know, that pale blue dot might be the only place in the universe where life exists. Conscious, intelligent life, capable of understanding the cosmos, might be even rarer. If that's true, then Earth's smallness takes on a different meaning. We might be tiny, but we might also be carrying something incredibly precious: consciousness, intelligence, the ability to understand the universe. These might be extraordinarily rare in the cosmos. Earth, small as it is, might be the only place in billions of light years where the universe has become aware of itself. That's a staggering responsibility. It means that what happens on Earth matters not to the universe, which doesn't care, but to the universe's ability to know itself. If we destroy ourselves, if we render Earth uninhabitable, we might be extinguishing the only light of consciousness in a vast dark cosmos. Looking far ahead, Earth's future is finite. In about 1 billion years, the sun will start to heat up as it ages. The oceans will begin to evaporate. Earth's surface will become increasingly inhospitable. Complex life will struggle to survive. In about 5 billion years, the sun will expand into a red giant, likely engulfing Earth entirely, or leaving it as a scorched, lifeless rock. But right now, right at this moment, Earth is vibrant and alive, teeming with millions of species, home to billions of humans, a world where consciousness has emerged and flourishes. Arguing on social media, that's happening on a dust speck flying through infinite emptiness. This story isn't meant to make you feel meaningless. It's meant to make you feel precious. We've taken quite a journey together. We started with Earth, our home, and zoomed out step by step. We compared it to the moon, the sun, and the other planets. We ventured to the nearest stars and discovered distances so vast they defy imagination. We explored the Milky Way with its hundreds of billions of stars. We saw galaxy clusters, superclusters, and the cosmic web stretching across billions of light years. Finally, we reached the observable universe itself, containing 2 trillion galaxies and 200 billion trillion stars. And through it all, one message became clear: Earth is small. Not just small, tiny, incomprehensibly tiny. When you compare it to the full scale of the universe, Earth essentially doesn't exist. But here's the paradox. Earth is infinitesimally small, yet it has produced something extraordinary: consciousness. intelligence, the ability to look out at the cosmos and understand it. We are quite possibly the universe's way of understanding itself. Through us, through our observations and our science, matter has become aware of matter. The universe has produced structures capable of comprehending the universe. That's either a common occurrence, repeated countless times across the cosmos, or it's extraordinarily special. We don't know which, but until we find evidence of life elsewhere, we must act as though Earth's biosphere, and especially its intelligent life, is precious beyond measure. Here's something that should blow your mind. Every atom in your body was forged in the heart of a star that died billions of years ago. The iron in your blood, the calcium in your bones, the carbon in your cells, all of it came from stars that exploded as supernovae, scattering their contents across space. Those atoms drifted through the cosmos for eons before they came together to form the Earth, and eventually to form you. You are literally made of stardust. But you're not just stardust. You're stardust that has become conscious. Stardust that can think, feel love, and wonder about its place in the universe. That's more remarkable than any galaxy, more extraordinary than any supernova. Size doesn't determine value. What matters is what exists here. And what exists here on this tiny planet is something remarkable. Life in all its diversity, consciousness capable of understanding the universe, art, music, love, joy, all the things that make existence meaningful. Earth might be small, but it's irreplaceable. It's the only home we've ever known, and in a universe that's mostly empty space, mostly cold and dark and hostile to life. A small warm planet teeming with life is a miracle. So, yes, Earth is tiny, but Earth is also home. Treasure it, protect it, explore it, take care of each other, because we're all we've got on this small world. The universe is enormous. Earth is small, but Earth is home. And sometimes, that's all that matters.